Imagine this! A game engine, powered entirely by a neural network, running the legendary game Doom at 20 frames per second, and guess what? It's doing it all on a single TPU. That's right, this isn't some theoretical future model. GameNGen is the first neural game engine, and it's already here, ready to change the way we think about gaming forever. Now, let me break this down. Video games, as we know them, have traditionally been crafted through painstaking manual work, coding every single interaction, designing every level, and fine-tuning the game logic. The classic loop: you input a command, the system processes it, and bam! Your game state updates. But with GameNGen, we're entering uncharted territory. The entire game is being generated in real time by a neural network. Yes, we're talking about a model trained to simulate not just images, but entire game environments. And this isn't just for watching, it's interactive. Let's get into the meat of it. This system doesn't just replay pre-rendered images. Oh no, it's simulating every frame, predicting the next one by conditioning on past actions and visuals. That means you're playing the game in real time. And this neural model is keeping up, delivering visuals comparable to what we'd expect from lossy JPEG compression. 229.4. PSNR, folks, basically this thing is crisp. But wait, there's more. Human evaluators who were tasked with distinguishing between the neural simulation and real Doom clips could barely tell them apart. They performed only slightly better than random chance. How insane is that? Alright, so how did they pull this off? GameNGen trains in two phases. First, a reinforcement learning agent learns how to play Doom, creating training data by recording every interaction with the game. Think about that for a second. Not only is the neural model predicting frame after frame, but it's learning from how the game is played. Then, a diffusion model takes over, trained on these past sequences of frames and actions to predict the next move. This isn't just some static simulation, it's interactive, allowing for long gameplay sequences with stability across long trajectories. And this brings us to one of the most fascinating aspects of GameNGen: how it stays stable. You see, with autoregressive sampling where one frame influences the next, there's a risk of the simulation degrading over time, like a copy of a copy slowly becoming unrecognizable. To combat this, they use something called noise augmentation, which deliberately adds some randomness during training to keep the system grounded and prevent these errors from accumulating. This is critical to ensure that the game doesn't just look good at the start, but maintains its fidelity over time. GameNGen absolutely nails it, achieving high-quality play over long sequences. Now, let's talk about the future. GameNGen is a proof of concept, but the implications are immense. It represents a shift away from traditional game development. Imagine a future where video games are no longer lines of code meticulously written by developers, but instead a set of neural weights that dictate how the game behaves. Entire worlds could be simulated from scratch, tailored specifically to the player's actions in real time. This could lower development costs, make game creation more accessible, and even open the door to new forms of gameplay and storytelling. Think about it. This model can simulate complex game interactions like tallying health, ammo, enemies, and navigating environments, not through pre-programmed code, but by learning what those actions mean from the gameplay itself. If we can extend this tech, imagine the creative freedom it could give developers. You could build entire levels, enemies, and mechanics just by feeding the model data and letting it learn how to create. This isn't just about Doom either. GameNGen could eventually apply to any game, or even interactive simulations outside of gaming. But we're not done yet. There's still work to be done. GameNGen currently runs at 20 FPS, which is impressive on a TPU but still leaves room for optimization. However, future iterations could push the boundaries even further, improving performance and even allowing it to run on consumer hardware. We're talking about a world where game engines could become as flexible and generative as today's AI art models. The dream? To create interactive worlds from mere text prompts or example images, all in real time. So, what's next? We'll need to tackle challenges around memory and context right now. GameNGen can only remember about 3 seconds of gameplay at a time. Imagine if we could extend that to minutes or even entire game sessions. The potential is limitless, but even at this early stage, GameNGen is laying the foundation for a future where games, simulations, and interactive environments are built and run by neural models. This is just the beginning, but man, what a start it is. So, whether you're a gamer, a developer, or just someone excited about the future of AI and interactivity, keep an eye on GameNGen. This is a revolution in the making. Like, comment, and subscribe if you're ready to see the future of gaming unfold.